This is a WEG CFW100 Inverter Drive, and in this video I'm going to show you how to connect external switches to start, stop and control the speed and direction of an electric motor. Hello, I'm Simon from the Inverter Drive Supermarket, and this is part 3 in our video series covering the CFW100 Inverter Drive from WEG. This video is loosely based on our free Easy Start guide, which can be downloaded from our website and printed if you want something to refer to. In part 2, we operated the inverter in local control, meaning the integrated operator keypad. Although this is convenient for commissioning, it isn't usual to control the inverter using the keypad in a production environment. It's much more likely that the inverter will operate in remote control, meaning operation is via external, i.e. remote switches, or another system. We can do this using the I/O terminals on the front of the inverter. As you can see, the CFW100 has 5 terminals as standard. Terminals 1 to 4 are the digital inputs. By digital, we mean that the signal is either on or off. By default, the CFW100 is set to NPN, or syncing, so a negative rather than a positive signal switches any of the digital inputs. Terminal 5 provides 0-volt ground for this purpose. We can change this to PNP, or sourcing, if we need a positive signal to switch the digital inputs. However, for this video, we'll stick with the default of NPN. I should mention that optional expansion modules are available to provide additional digital outputs or various combinations of analog and digital inputs and outputs. We'll cover these in later videos, but for now let's focus on these 4 digital inputs. To get started, let's first change the control to remote. Press the P key to find parameter P220. It's currently set to 0 for always local, meaning the integrated keypad. Change it to 1 for always remote and press the P key again to save. Now press the Run Stop button. Nothing. This is as expected. From now on, we'll need to use one of the digital inputs to start and stop the motor. We can assign each of the 4 digital inputs to a different function. Examples include run stop, direction of rotation, jog, quick stop, reset, and so on. The values range from 0 to 57, so pause the video here to see all the options. To set the function for each digital input, we can set parameters P263 through P266. P263 sets the function of digital input 1, which is the terminal labelled 1. The default value is 1 for run stop. P264 sets the function of digital input 2, which is terminal 2. The default value is 8 for direction of rotation. P265 sets digital input 3, which is terminal 3. The default value is 0, which means it will not be used and any input will be ignored. P266 sets digital input 4, which is terminal 4. As you can see, the default value is also 0. So if we link terminals 1 and 5, digital input 1 will be active and the motor will start. Let's try it. The motor starts. To stop it, we simply remove the link. This demonstrates the theory, but we'll need to add some switches to do this properly. In many cases, the switches will be mounted on a control panel door, but for simplicity, I'm going to use one of WEG's control pendants. As you can see, we're using the 4-position version, so we have 1 switch for each digital input. These are easily fitted to the front of the pendant. We're using switches, not push buttons, so the signal the digital inputs will see will either be on or off. We'll look at momentary signals from push buttons later in the video. The switches operate contacts which clip onto the back of the pendant. Both normally closed and normally open types are available. The green ones we're using here are normally open, so complete the circuit when pressed. To connect the pendant to the inverter, we first common one side of the switches so that they can be connected to the 0-volt ground on terminal 5. We then connect the control cable. Notice that I'm fitting a 20mm gland to keep the dust out. Once the 0-volt ground is connected, a wire for each digital input is connected to the other side. Each wire is numbered, which will be handy later. Now all the wires are connected, we can fit the front of the pendant. And finally, add labels so we can identify each switch. At the inverter end, the 0-volt ground is connected to terminal 5, and the wires labelled 1 through 4 connected to the matching terminals. WEG recommend that the control cable is screened, so you can see that I've exposed the screen as a pigtail and connected it to an earthing point on the cable clamp plate. This should provide some protection from interference, and it's also good practice to keep the control cable away from the power cables. So, now everything is connected, let's try it out. The default value for digital input 1 is start-stop, so switching DI1 on the pendant should start the motor. It does, excellent. And the default value for digital input 2 is direction of rotation, so the motor slows to a stop and then rotates in the other direction. Perfect. DI3 and DI4 are not used by default, so nothing happens when I switch them. Great. Okay, let's look at a few more examples. The first example is jog. This will give us the ability to press and hold a push button to run the motor slowly. I'm going to use digital input 4 for this, and I need to swap the switch for a push button. This blue one should do the job. No wiring changes are necessary. The value for jog is 10, as you can see, so we need to change parameter P266 from the default of 0 to 10 to change the function of digital input 4. We also need to check the value of parameter P228 to make sure that the value is 2, so the remote jog selection source is one of the digital inputs. The jog speed can be set in P122 and the default value is 5. However, it will be overridden by the minimum speed set in P133, so check this value if the jog speed is faster than expected. I'll select parameter P002 so we can see the output speed. Okay, now when I press and hold the DI4 button, the motor runs at 5 Hz and stops as soon as the button is released. That's the jog example complete. Let's move on to 3-wire control. For this, we'll change the switches connected to digital inputs 1 and 2 to push buttons. Then we'll reconfigure these two inputs for push to start on digital input 1 and push to stop on digital input 2. I'm using the standard green for start and red for stop. We'll also change the contact on digital input 2 from a normally open to a normally closed type. You can tell the difference by the colour, as the normally closed contact is red. In 3-wire control, a momentary contact on digital input 1 will start the motor, and it'll run for as long as the digital input 2 contact is closed. A momentary break on this contact will stop the motor. This is why we need to change to a normally closed contact. We can use parameters P263 and P264 to set up 3-wire control for digital inputs 1 and 2. First, set P263 to 6 for start. And press P to acknowledge the conf message. Then set P264 to 7 for stop. This also fixes the configuration error. Now when I press the green button, the motor starts and keeps running until I press the red stop button. Simple. For the next example, I'm going to enable the electronic potentiometer feature on digital inputs 3 and 4. I'm going to swap the switch on digital input 3 for a black push button. This will allow us to raise the speed by pressing the blue push button connected to digital input 4 and lower the speed by pressing the black push button connected to digital input 3. This is a good example as the CFW100 doesn't include an analog input as standard, which means we can't add a physical potentiometer to control speed. An analog input is available as an optional I/O expansion module, but we'll cover this in another video. Now that I've fitted the push button, we can configure the digital inputs. WEG use the abbreviation EP for electronic potentiometer, so we need to set P265 to 12 for decelerate EP. Press P to acknowledge the conf message. Then set P266 to 11 for accelerate EP. We also need to set P222, which is the remote frequency reference, to 7 for electronic pot EP. This also fixes the configuration error. I'm also going to set the acceleration and deceleration time to 10 seconds using P100 and P101. This step is not required and is just for the purpose of this video, as it will allow you to see the change in speed more clearly. As before, I'll select P002 so we can see the output speed. OK, press the green button to start the motor. Then we can press and hold the blue button to increase speed. And the black button to decrease the speed. If I press and hold the black button, the motor will stop decelerating when it reaches the minimum speed. For the final example, we can combine the function of both 3-wire control and the electronic potentiometer into just 3 buttons. So the green start button becomes push to start and push again to increase speed, and the black lower speed button becomes the push to lower speed and push to stop. The red stop button remains, and we can swap the blue raise speed button for a switch to change the direction of rotation. This provides quite a bit of functionality for just 4 digital inputs. To set this up, change parameter P263 to 37 to set the digital input 1 to start and increase electronic potentiometer. This is the green button. Press P to acknowledge the conf error. Change parameter P264 to 40 to set digital input 2 to safety switch. In this context, safety simply means we can use the normally closed contact as before. This is the red button. Change parameter P265 to 38 to set digital input 3 to decrease electronic potentiometer. Stop. This is the black button. And change parameter P266 to 8 to set digital input 4 to direction of rotation, the switch. This also clears the configuration error. Let's try it out. To start the motor, we simply press the green start button. To increase speed, we press and hold it. To decrease speed, we can press the black button. We can lower the speed all the way to the minimum speed, and then press it again to stop. Or if we start the motor again, we can use the switch to change direction. Notice that the motor runs at the same speed, just in the opposite direction. And press the red stop button to stop as before. Okay, that's it for this video. Thanks for watching, and I hope you'll join me in the next one where we'll look at multi-speed control via the digital inputs. If you found this video helpful, please give it a thumbs up and consider subscribing, as we really appreciate your support. See you next time.